So now let's proceed with our topic for today. Okay. I know you're excited on this discussion because this is the practical applications of Open RAM. And we also want to share with you some of the learnings we've got during the US tour last week. So what you can see here is an Open RAN uh, system built by Dish Network. So they are located in Denver, Colorado. Okay. So this is a cow system. So everybody knows cow. So for those who are not familiar with the word cow, COW, cow means cell site on wheels. So this is the type of open run system that they already built. So everything that they deployed in the Dish network is already Open RAN. Okay, so it's easier for them to deploy Open RAN because they are a greenfield operator. Meaning greenfield, they don't have an existing network yet. No? So when they start to build the wireless network like 5G standalone, they built in on an Open RAN platform. Okay, so this typical example of an Open RAN system. So what we're trying to say here, it's happening already, especially in the US. Okay. All right. So we have an exciting topic today, as I mentioned, because we also have another guest speaker in the second half, another expert in wireless telecommunications. So I will be balancing the presentation so that we can maximize the time. Okay, so our topics are the following. So we'll have a review or an introduction to RAN and Open RAN. And then I'll introduce to you the ORAN Alliance, who is ORAN Alliance, and the ORAN technical priorities, and some ORAN use cases, and some key learning points, and then probably Q&A. We'll move it at the end of the session of the second speaker later on. Okay, so the Open RAN use cases is one of the courses under the advanced course in Asia Open Academy. And it covers the ORAN Alliance several use cases and phases. Okay. Hold on. Okay. So it includes the ORAN technical priority document, which contains the list of prioritized technical requirements. And some ORAN use cases from the phase 1 and phase 2 are highlighted as well. Okay, so let's start with the introduction to RAN and Open RAN. Of course, when we try to discuss what is RAN or radio access network, we'll go back to the basics of wireless telecommunication system. So let's have a review of the wireless telecommunication system, which we discuss in the basic or the foundational course no, under the radio access network. Okay. So in a wireless telecommunication system, it is composed of three main parts. No? It's an easy of one connecting the dots from 1, 2, and 3. So the first part is the user terminal. So the user terminal is also known as the user equipment or UE if you are talking about LTE or 5G or 3G. And if you are talking about 2G, we call it the mobile station. Okay. So these are the devices used by the end users to connect to the radio access network or RAN. So the RAN, on the other hand, is responsible for providing the wireless connectivity and required for mobile devices to connect to the core network. So in common term, the radio access network is also known as cell site. And also the RAN or the radio access network has different names as well. It depends on the type of technology. So if it's 2G, we call it the base transceiver station or the BTS. If it's 3G, we call it the node B. And if it's 4G, we call it the evolved node B or E node B. And for 5G, in this example, we call it the G node B. Although in the 5G system, you will learn that there's a lot of terminology in terms of 5G, depending on the architecture or implementation of the system. Okay, but in this example, we will call it G node B or the next generation node B. So the RAN and the user terminals are connected through the air interface or what we so called the radio frequency. Okay, so this radio frequency, this one. Okay, and RAN in the Philippines and in the other country are operating in a different set of frequencies, right? So we have FDD, or the frequency division duplex, and the TDD frequencies. So it starts from 450, 900, 850, 700, 1800, 2100, and so on. Now, the radio access network will be connected to the core network. Okay, so the core network is one of the intelligent part of the network, or the most intelligent part of the network, which is responsible for managing the overall operation of the network. That includes routing of traffic between different networks and providing advanced services such as voice calling, messaging, and data services. In the core network as well, this is the place where you can see if the subscriber is a prepaid user or a postpaid user. Okay, so there's a lot of things happening in the core network. So the connection between the RAN and the core network is called the backhaul system. Okay, so the backhaul could be a microwave, a wireless connectivity. So if you're using different kinds of microwave antennas like this, so we call it a microwave. Or we can connect these two using a fiber optic cable. And in some scenarios, we use the satellite, so satellite connectivity. Okay, if there's challenges in terrain or laying out of fiber optic cable. Okay, so these are the types of connectivity using the backhaul. So it is as easy as connecting the dots from 1, 2, and 3. So you need to have a user terminal, you need to have a radio access network, and you need to have core network. So in all technology from 1G, 2G, 3G, 4G, or even 6G, you need to have these three major parts of the wireless telecommunication system. Okay? So we need the RAN in order to provide mobile coverage. Okay? So we place the radio access network or cell sites in strategic locations, okay, to provide wireless coverage to users within a specific geographic area. So you can see here in the right corner, we are building different sites, in different parts of the country. So the placement of the radio access network or cell sites are critical to ensure the users will have a reliable and consistent access to the network services they need. So when planning the deployment of radio access network, so the network operators like Globe, Smart, or Dito consider various factors. So that includes population density, how many people are living in that area, the topography, the building density, and the traffic patterns within the coverage area. So by analyzing these factors, so network operators can determine the optimal location and configuration of the RAN components to ensure the maximum coverage and capacity. So for example, in some urban areas like Makati, Bonifacio Global City, or Quezon City, with high population density and building density, so the network operators may need to deploy more cell sites with lower output power to provide coverage to smaller areas. However, in rural areas like in the different provinces of the Philippines with lower population density, so the network operator may need to deploy fewer cell sites, but with higher output power to provide coverage and to provide coverage to larger areas. Okay. So the placement of radio access network, okay, are also affects the overall network performance, such as the call quality. So if walang site dun sa area, so it will affect yung quality ng call ng mga subscribers. That includes also data speeds and of course the network capacity. Okay? So we are putting different cell sites. So overall, in some operators, the number of cell sites are ranging from thousands, for example, 10,000 to 30,000. And in some other countries, they are ranging from hundred thousands. And there are countries like China that almost reach a million cell sites. Okay? Hindi natatapos yung cell site building. Alright. Ayan. So thousands of front elements create seamless coverage and mobility. Okay? So that's the reason why we're building a lot of cell site. Okay? Natapos din yung pagbibuild. Okay. All right. So, but building a cell site or radio access network impose a lot of challenges, no? Especially for telco operator. Okay. So, what are those challenges? First is the faster time to market. Okay, faster time to market. So, what does it mean? No? Especially if there's a new technology like 5G. Okay, so it needs a faster rollout for new features, services, and capabilities. Like for example, you're hearing now 5.5G, and previously meron tayo for 4G, 4.5G, 4.75G. So that means the rolling out of new features and services. And in some cases, they need to roll out new cell sites. No? They need to build a new tower. So that is one of the challenges. And rolling out these new features, services, and capabilities, it will require significant investment, in new networking technologies. And of course, there's also a challenge in flexibility. How can we reuse the existing equipment, the existing software, okay, the existing resources for us to deliver these new services? So that is one of the challenges, the faster time to market. Next challenge is better performance. Okay, better for performance. So this includes expansion and improving the system capacities, especially if there's a lot of users already camped in the network, and those users are accessing different services, and they are heavy data users, no. And in some cases, uh, we need to have a better coverage, especially indoor solution. This happens during the pandemic, where almost everybody are accessing the site indoors. Almost 70% of subscribers are accessing the site indoors. Now, the problem came when there is no sufficient coverage indoor. Okay, so that affects the performance of the network. And of course, enhanced quality of services. Okay, so quality of services means for different services, there's a different priority in the network. So if you are accessing the network or using voice services compared to data services, so you do have a different quality of services. So those service needs to have a better quality of or QoS. And of course, the last one is to lower the cost of implementation. Okay, so number one is to cut in energy consumption. In the deployment of radio access network, almost more than 50% of the power is being utilized by the radios or the RRUs. Okay, so these are the heavy uh, uh, power users, in the network. And lower equipment costs. So if you build a new site, so it will require new equipment, and the cost of equipment is not so cheap, no? So it's expensive. So that's why we need to have a lower equipment cost before, so that we can maximize the deployment of the sites. And of course, the reduced capex and as well as the opex. Capex means capital expenditure. These are the costs incurred when you are trying to build a new cell site. Just like buying a car. If you will buy a car, the money that you will pull out of your pocket to buy the car, we call it the capex. Okay, but the opex is another thing. So once you bought the car, there are operational expenses like gasoline or diesel. You need to buy insurance. You need to buy for maintenance. You need to change tires. Okay, so those are the operational expenses. So when you combine this together, we call it the total cost of ownership or TCO. Okay, so there are cell sites, especially for new cell sites that needs to have a new tower. That's bigger cost, for operator. So we want to solve this kind of challenges for the in the operator side. And one of the solution that came out is the Open RAN. Okay. So what is Open RAN? So Open RAN means Open Radio Access Network. So this is an industry movement. It's not a new technology, but an industry movement, new way of implementing a radio access network or cell site. It develops a disaggregated, so meaning the hardware and the software are now separated. That's why there is a terminology sometimes people saying open run is a broken run. No? Well, that's in another sense, it's correct because it's you are disaggregating the hardware to software. And the good thing is it should be interoperable radio access. Once you separate the hardware to the software, you can mix and match. Okay, essentially those two entities or different entities. That's why it should be interoperable. Now you will see in the in different countries such as US, there's a lot of interoperability lab, meaning they are testing different equipment to different software, different hardware to different hardware. They connect it, so they try to do to do some interoperability testing. So to ensure that when they deploy the radio access network or the Open RAN, it can work, no, and will have limited or very few problems or challenges. Okay, so that should be interoperable, and it will also leverage the what we so called the general purpose processors or GPP hardware. So we call it also the white box hardwares. No, so you can buy a commercial off the shelf servers like what we can get from Dell or HP, and then you can install the software of another vendor to that one. So we call it the general purpose processors. And at the same time, there is what we so called the software defined technologies. So where you can configure the the config the capabilities of your RAN through software definitions. So it's easier for you to upgrade the capacity or to modify the capabilities or program the capabilities of your radio access network. And of course, if you want to have interoperability of one equipment to another equipment, you need to have an open interface such as this. Okay, so another radio equipment, like for example, coming from Mavenir, will work with a Nokia baseband unit or a Fujitsu radio unit can be connected to an Ericsson baseband unit. Okay, or um, a parallel wireless radio connected to a COT server powered by a Mavenir software, something like that. Okay, so that's it. That's where the flexibility of Open RAN, and it gives more room for operators to do or to implement the radio access network at their own freedom. No? So that's why the pillar of Open RAN is enclosed in this four items. No, openness, so they know what's happening in the inside the box, and virtualization. Okay, so they can um, deploy the software or the capabilities using software-defined technologies. And of course, when implementing Open RAN, you will see later on in the architecture that there is what we so call the RAN intelligent controller. The RAN intelligent controller, most of the operators or vendors that we have talked in, especially in the US, they call it the crown jewel of Open RAN because this will be the differentiator. The the more intelligent RAN intelligent controller you have, the more capabilities your radio access network could have. No? And of course, the programmability. Okay. So this is the Open RAN. So how do we compare it no, to an existing RAN? Okay. So if we compare it, so if, for example, if what you see right now in the implementation of RAN, these are what we so call the traditional RAN or proprietary that uses proprietary hardware and software. So we call it a black box. No? So especially you will buy one BBU or baseband unit from a specific vendor, and it comes with the software coming from that vendor. and then including the front hall or the interface together with the radio. So essentially, you can only implement a run from a specific vendor. Sorry. Cannot, sorry. From one specific vendor. Isang vendor lang, no? So if this is vendor A, this is only vendor A only. Antennas, you can use other brands because most of the antennas that we are implementing are passive. Okay, so you can use any antennas that you might use. But if you are using a massive MIMO antenna, which is a combination of these two form factor, so you need to buy to another to a one single vendor only. So the challenge of this is that the operators are locked in. They don't have any choice but to buy to this particular vendor that they have initially engaged. So they can wait for upgrades if there's any. And if they are asking for some additional features, they need to wait for development of that features. Okay, so there's a locked in. So the flexibility is not so what we call flexible. Okay, so that is a traditional run. Now, when we go to Open Run, you will see here that Open Run are using a COTS server or commercial off-the-shelf server or a specialized server for telecommunications. And then you can install software from different vendors as well. And the radios also, you can connect with this kind of baseband units. Any vendor, for example, from Avenir, Fujitsu, Parallel Wireless. Okay. So you can connect. So you can mix and match this equipment and software. So you have the flexibility. The vendor, the operator has a flexibility on how to deploy their network. So if they don't want the performance of one vendor, they can replace it with another vendor. So that's the concept. Although, of course, that's easier to be said than done, right? So because in the actual deployment, so there's still a challenge, no? So especially in this stage, there's an issue on the network performance. Okay, not an issue. There's a concern on the network performance. So that's why there is testing that is happening. Imagine, we are still on the early stage of Open Run, and everything that is in the open stage, there's still a trial and error happening. There's a lot of testings happening. So I cannot blame the other people that there's still a lot of cynics about the Open Run. But if you can see as as a technology or the movement progress, there's a lot of improvement that will happen. And eventually, when we are talking about new Gs happening, so the Open Run could be one of the differentiator of implementing it. Okay. So it's okay for everybody to become a cynic of Open Run. No problem on that one. Okay. So fault management. So if you're using a different vendors or different operator or different software, so who will be taking care of the fault management? So that's one of the challenges. No? Of course, network automation, and then you need to understand the Open Run ecosystem, and of course, new team profiles. Okay, you need to train people, especially in one operator that we've met. Most of their RF engineers are also capable of IT skills. Okay, so programming skills. So for example, not all RF engineers or telco engineers are capable of programming a RAN or are handling network systems. Although they are very good in terms of RF, but they are not so skillful in terms of the network or the IP technology. So you need to build a new skill set of your team, okay, for your team. So that's why it needs a new team profiles, okay. And so those are but there's still a benefit, so we already have this kind of benefit. So you need to you can have a diverse vendor ecosystem, network innovation models, introduction, and then lower total cost of ownership. Okay. Okay, so in the implementation of Open Run, of course, there's a lot of groups and initiatives that are involved. First, of course, it's a 3GPP, or the Third Generation Partnership Project. Okay, so this was established in 1998, and 3GPP defines the 3G, 4G, and even the 5G standards. Okay, including the functional split, radio access network, which includes the Open RAN, and the front haul, the F1 mid haul, between the DU and the CU. TIP, Telecom Info Project, established in 2016. This is where Open RAN was first conceived, and TIP has a multiple Open RAN product implementation project groups, and it is funded by or founded by Facebook or Meta. And of course, Oran Alliance, which was established in 2018, they are the one who are developing the architectures and specifications for Open RAN. So later on, we'll focus on the Open RAN Alliance or the Oran Alliance. We also have ETSI, or the European Telecommunications Standards Institute, promoting Open RAN adoption in Europe. The GSMA, okay, GSM Association, which represents the global telecom operators, helping operators commercialize Open RAN. The next generation mobile networks. So these are the collaboration of operators. Okay, so it's collaborating with the ORAN Alliance to accelerate the standardization and adoption of Open RAN for 4G and 5G. And of course, the Linux Foundation. So this is a non-profit consortium created in 2020 by the Open Source Development. And this is a free standards group. No? It promotes a standardization unit of Linux for commercial use. And we will use this as software development for Open RAN. And ONF, Open Networking Foundation. And of course, for the SEF, the Small Cell Forum. So these are the organization that develops Open RAN with the small cells in mind. Okay, so implementing indoor solutions. Okay, so these are the different parties and groups and initiatives now involved in the Open RAN. But in this discussion, we will focus on the ORAN Alliance. Okay, so which defines the architecture and specification of Open RAN. So let's move on to ORAN Alliance. So who is ORAN Alliance? No? So ORAN Alliance was funded in 2018. No? So it is a combination. It's a merging of two distinct groups, the CRAN Forum and the XRAN. Okay, XRAN Forum. So they merged together to form the ORAN Alliance in 2018. Okay, so the founding operators is AT&T, okay, in US, China Mobile, Deutsche Telekom, NTT Docomo, and Orange. So these are the major telecom operators in US, China, and in Europe. Okay. So the ORAN Alliance, this was formed in February 27, 2018, with the goal of promoting open and intelligent RAN, and the second organization driving the Open RAN movement. So the first one was Telecom Info Project. Okay, Telecom Info Project. Okay, so the ORAN Alliance is, as I mentioned, is a group of telecom companies that aims to improve the performance and openness of their network. Okay, so they want to have a more intelligent network, and the use of artificial intelligence and machine learning can be applied to this collected information. So now let's watch some video about ORAN Alliance. So to further know, or for you to become more familiar, who is ORAN Alliance, especially if you are very curious on studying the specifications of the Open RAN architecture. So let's watch this video.
Transforming radio access networks to be open, intelligent, virtualized, and fully interoperable is not a far-off vision. The ORAN Alliance has made this vision real. Since 2018, the adoption of the ORAN Alliance by the industry has been incredible. It has grown to a worldwide community of operators, vendors, and research and academic institutions jointly developing a sustainable O-RAN ecosystem. Through expanding traditional mobile networks, the O-RAN Alliance has created its O-RAN architecture to become a foundation for truly open and intelligent radio access networks. The O-RAN architecture improves the RAN in several areas. First, the O-RAN architecture supports disaggregation of software from the hardware and network virtualization. Underlying open reference design hardware and the O-Cloud provide a high-performing and scalable computation layer. Second, the O-RAN architecture is based on well-defined open interfaces to enable a multi-vendor, interoperable supply chain ecosystem. Third, the O-RAN architecture empowers mobile networks through artificial intelligence and machine learning. O-RAN networks can self-optimize to ensure the best possible service for the end customers, and automated operations and maintenance enable more efficient network rollout and operations. Defining the complex O-RAN architecture is a step-by-step process, resulting in hundreds of technical documents. To ensure compatibility and to avoid duplication of work, the O-RAN specification effort builds on common standards and cares about alignment with other industry bodies. O-RAN specifications serve as a basis for open software reference design. The O-RAN software community hosts developers brought in by many O-RAN players, cooperating on tens of software projects. O-RAN specifications in open software are enabling a broad industry ecosystem. Companies of different sizes and competencies can use them to create their innovative and competitive open solutions. In addition to specifications, O-RAN Alliance supports the ecosystem in testing and integration. O-RAN Global Plugfests allow companies to demonstrate component functionality as well as multi-vendor interoperability. Moreover, the open testing and integration centers around the world will offer a collaborative and impartial testing environment. O-RAN supports implementations using open source modules, proprietary modules, or any combination. Operators and suppliers can create different paths and approaches to implementing O-RAN, optimized for their specific network and customer needs. The rapidly emerging O-RAN ecosystem has enabled service providers on multiple continents to start field trials and commercial deployments, aiming to build significant parts of their networks based on O-RAN technology. Open, intelligent, virtualized, and fully interoperable, O-RAN-powered mobile networks will soon be serving billions of people around the world. The O-RAN Alliance.
Okay, so that is O-RAN Alliance. So I will be you can just visit the website of the O-RAN Alliance. Just type in sa Google yung O-RAN Alliance. So you can easily find this website. Actually, when I first saw this website way back 2019 when I was in Myanmar, I got interested in the technology. So I tried to study Open RAN at that time. So I was trying to read about Open RAN, and then essentially we see that there's a potential of this new movement in the radio access network, especially if you're looking at the new Gs coming in like 6G, which will be based in an open RAN in an open system, okay, powered by artificial intelligence. So you can see the trends that will happen in the future as well. Now let's move on to the global landscape of Open RAN. If you will see the deployment of Open RAN, so you can see this is the website ng Open RAN. Okay, so this is the website of Open RAN, and then you can see here as well the O-RAN map. Okay, I will just click the link and then share with you the link so you can also browse it. Yan. So sorry. Nakaano lang pala to. Okay, yeah. So I shared in the chat box the link. Now, if you want to see the different activities happening around the world, in the Open RAN, so that you will not be confined in the context of the Philippines. Because if you just look into the Philippines, we are not there yet. But if you look at a global scale, you will see that there's a lot of happenings already in terms of the Open RAN. Now, if you look at the map, okay, if you look at the map, you will see the different testing centers, some field trials, deployment, commercial launch. Okay, so if you click the commercial launch, okay, so there are already um, sites or areas that already launched no yung Open RAN. But there's a deployment yan. Ito Open RAN and deployment. Okay. Oh, sorry. Ayan. So the one of the um what do you call this deployment no is already in Japan, which is Rakuten. Okay, Rakuten and NTT Docomo, they already have commercial launch. Okay, so Rakuten is here in the Philippines. You can see it's in the Viber. No? One of their product is Viber, but in Japan they are one of the greenfield operator as well. So they already deployed Open RAN. And another one is in the US. Okay. So in the US, you can see Dish Wireless. So this is the one that we also visited during the US study tour. So we saw how they deployed or how they are building their network using Open RAN. Maybe in some other future we'll have a more discussion about how Dish are deploying their Open RAN. So we can have a separate session on that one. Okay. And in some other countries, there's still a lot of trial happening. Okay. So you can play around with this Open RAN maps, and then probably if you're one of the cynics of Open RAN, you might see some opportunities, especially for your career in terms of Open RAN. Okay. Okay, so what's already in the market now? What's already available in the market? Okay, so if we will see the ecosystem of the Open RAN and the value chain, you can see that there are already semiconductors that are involved in developing Open RAN. So that includes the general purpose processors like AMD, ARM, Intel, and NXP. There are also specialized chipsets. So these are primarily on the electronic sides, no? Semiconductor chipsets and components that are already supporting the production of Open RAN. Okay, so NVIDIA is also there in terms of the acceleration of the servers. Qualcomm, one of the leading developers of technology, especially in 5G, and the analog devices, Texas Instruments, already jumping into the Open RAN. In the ORAN hardware, you will see some ORU. So these are the radio units. You can see different vendors like Airspan, Bicel, Comba, Comscope. If you're familiar with these brands or logos, Fujitsu are there, Mavenir, NEC, okay, and WNC or Foxconn. In the domain of open, distributed, and centralized units or the ODU and the OCU, Dell is already there. Hewlett-Packard, Contron, Supermicro, and QCT. And for the full RAN, of course, these are the existing vendors like Ericsson and Nokia, and of course Samsung. Now, if you move on this ORAN software, so this is the software that you install in your ODU or OCU. We have Capgemini, GMA, JMA, Mavenir, Nokia, Parallel Wireless, Samsung, Rakuten Symphony is also there, and Radisys. Now, for the RAN Intelligent Controller or the RIC, so there's a lot of players also involved, like Juniper, Mavenir, Cellwise, Capgemini, Nokia, VMware. And for the service management and orchestration, you will see Amdocs there, Ciena, Ericsson, Juniper, High Street Technologies, Samsung, and HCL. So those are for the ORAN software. Now for the services, before the services, we have for the cloud. I believe a lot of participants here are very familiar with the brands in terms of the cloud. You will see that there's a lot of familiar brands or familiar companies already in the cloud domain. That includes Dell in the cloud hardware, Hewlett Packard, Lenovo, and Vapor. For the cloud software, AWS is there, Canonical, Google Cloud, Microsoft Azure, Red Hat, VMware, and for the public cloud providers, so these are the famous or the familiar brands that you will see. Now, what does it mean? No? So, meaning it's a combination of skill set of IT, networking, and telecommunications. That's why in implementing an Open RAN, you don't need to have only one skill set. It's okay. So you need to have uh, the following skill sets that these services or products are offering. So in terms of services or integration, we also have Accenture, okay, NEC, Amdocs, Tech Mahindra. For the test measurements, so when you are trying to test the performance of your RU, the CU, the DU, or the UE, Anritsu is there, Rodensward is there, Aspirate is there, Keysight, in Viavi. Keysight is also known as previously was known as Agilent. Okay, and then Viavi is also one of the major test and measurement vendors. Enterprise services, we have Cellnex, Cisco, Nokia, Ericsson, and ServiceNow. Okay, so there's a lot of players already that is available in the market. Okay. Now let's see, no, what is the ORAN logical architecture? Okay, so this is just a review, no, coming from discussion by Dr. Josel Reyes last time about the Open RAN architecture during the basic Open RAN course. So you have the service management and orchestration. Okay. Let me just put my point down. Okay. So this handles the deployment and configuration, okay, as well as the collection of the run functions. No? Yeah. And then it contains the non-real-time rate, which processes the information of more than 1 second. And then there's also what we so-called the R apps, no, that embedded in this system. And then we also have this near real-time RIC. Okay, so that handles the processes or the services less than 1 second. So just to push down, no, all the policies from SMO going to the E2 the nodes, no, the E2 nodes such as the CU, the distributed unit, and the radio unit. Okay. Now the CU and the UP, previously we call it the baseband unit. Okay, so when 5G came in and then the functional split are being introduced, we split the baseband unit functionality into the centralized unit and the distributed unit. And the RU is still there, which handles the radio functionality of the system. So this could be the 5G system. And if you have 4G implementation, you have the OE node B. Okay. And the physical infrastructure, okay, or comprising the collection of the physical infrastructure nodes to meet the ORAN requirements and to host the relevant ORAN functions, we call it the O-Cloud. Okay. So this is the fundamental ORAN logical architecture. Now, if you will look at this, no, into a physical system itself, you have this SMO. Okay, so this is still the SMO in much more detailed architecture. No, so you have different functionalities inside the SMO, and then you have the RIC. Okay, the RAN intelligent controller, which can be embedded on this sample of Dell servers. Okay, when you go into the laboratory or implementation of Open RAN, what you will see on the SMO and the RIC is just like this. Okay, it's like a typical Dell server. Okay. Now, if you go to the CU or the centralized unit and the distributed unit, so this is how we reflect it into an architecture drawings. But if you will go on site, what you can see is just like typical server as well. So this is the DU and the CU. Now, if you will go for the radio unit like this, the radio units are here. So this is a typical setup for Mavenir. Okay. And antenna is like this. So this is typical special antenna. No? It's an omni antenna. But there's a lot other types of antenna. There's a panel antenna. But this setup is a good example for you to visualize the architecture and how to identify it if in terms of the physical interconnection. Okay. Okay. So this is how no, the typical setup of Open RAN system. Of course, in the laboratory, in for research, it's a different setup. Okay, so we have different setup of Open RAN, especially for testings and research purposes. So for testing, like this one, this is also an open source 4G, which is based on Open RAN system. We call it a fire cell. So it's a lab kit. So this is designed to for teaching purposes and for implementation of Open RAN for a private network. So if you want to do some private network testing or implementation, if you have some frequencies like in the US, they have a certain frequency, they call it the CBRS, the Citizens Broadband Radio Service. Okay, so that is operating on the 3.5 gigahertz. So everybody that can operate in that frequency don't need to have a specific franchise to operate on that band. So everybody can or can perform or implement Open RAN using the lab kit. Now, in terms of on the plug fest, this is the plug fest where we can see how they are testing each component of Open RAN. So if you want to test the functionality of your system, some companies they use an emulator. We call it the UE emulator. So this is the type of UE emulator. So coming from Spirent. So the UE emulator, as the name suggests, emulates. Ginagaya niya yung performance or yung functionality ng isang telepono. But in the UE emulator, you can configure up to 1,000 or 2,000 UEs in your system compared sa isang telepono lang compared to one phone lang. And then you will connect it. But if you are using a UE emulator, thousands of cell phones can be emulated. And then you will see how your system will behave. No? Instead of deploying it in a actual setup, so you will set up inside the laboratory. Okay. So this is a typical setup of a plug fest. And then there's implementation already, like the Lions, the technology of community networks. Okay. Okay, so what are the benefits of ORAN architecture? So first, the ORAN can reduce as they claim, particularly in Rakuten, they say the network capex has been reduced by 30%, 40%, and then OPEX is 30%. No? And then can improve network efficiency and performance, and also can import new capability with great agility. Now, in terms of the use cases, when you look at the ORAN Alliance, they divided the use cases into two phases, phase 1 and phase 2. So phase 1 includes the low cost, RAN white box hardware, traffic steering, QoE optimization, massive MIMO optimization, and also the QoS based resource optimization. So these are the different phases of the different use cases under phase 1. Under phase 2, RAN sharing, so where two operators can share the radio access network. RAN slice service level assurance, context-based dynamic handover management, especially for V2X. Okay, so for autonomous driving, and for flight path-based dynamic or UAV. So we saw this in not an Open RAN system, but the application of unmanned aerial vehicle or drones. In the application in the University of North Carolina. Okay, and radio resource allocation for UAV applications. Okay. Of course, when Open RAN or the ORAN Alliance defined the specifications, maybe a lot of developers might produce different specifications and different combinations. So that's why the European operators um, agreed, no, or signed a memorandum of understanding to define the ORAN technical priorities. Okay, so the ORAN technical priorities, this was created by the European operators that actively embracing the Open RAN movement. So they are seeking to transform their networks and drive innovation in the telecommunications industry. So they define what are the different priorities that we need to develop in Open RAN para hindi sabog-sabog no yung the development no ng technology. So they pointed out the technical building block requirements no in each major domains. Like for example, in the cloud infrastructure, the all cloud platform should be based on the Kubernetes, supporting the necessary run software. No, so to become the mainstream of implementation. For the OCU and the ODU, so they are implemented as CNFs on power efficient and reliable GPP CPUs and with hardware acceleration support. Yeah. For the ORUs, there are also different specifications like the frequencies, the multibands, or for the definitions of specifications for the AAUs as well. There's also a definition of the open front hole, RAN features. For example, for the RAN features, both 4G and 5G are targeted and should be both also based on NSA and SA in terms of 5G architecture for single operator and RAN sharing scenarios. Okay, so they want to have these features on the in the Open RAN system. No? For the RIC, also there's also in terms of intelligence and programmability, automation, SMO, energy efficiency, okay, security, of course. So this is a global priority for the operators that require strict policies and features across all entities of the Open RAN network. And of course, high availability. Now, if you look at the Open RAN technical priority document, you can see it also in the ORAN Alliance website. You can download this document and this Excel file. So in the Open RAN technical priority document, they have what we so-called the priority 0 and priority 1. Priority 0 simply means mandatory or must have. Priority 1 are nice to have or optional or should support. Okay. And each priority, the 5 operators voted if they want to have it P0 or P1. So unanimity means all 5 operators have corresponding priority. So ibig sabihin, lahat sila nag-agree that this is priority 0. And majority, 3 or 4 operators have corresponding priorities. And then minority would be 1 or 2 operators. Okay? So let's see no kung ano yung mga technical priorities na yan. For example, traffic steering. Yeah, so this is a RAN feature. Traffic steering, so they consider it as priority 0 and unanimity. Okay? So all 5 operators agree that this is a very important feature no in Open RAN system. Like for example, RAN sharing. Okay, massive MIMO optimization. So these are all priority 0. But there is a priority 1, which is the content-based dynamic handover management for V2X. Probably some of the operators that did not vote don't see any use cases yet no for a V2X application, meaning vehicle to everything application. That's why they did not vote it to become a priority 0. Now, if we look at the different technical priorities in terms of implementation. So there is a different implementation for macro and for RAN sharing. Okay. Okay. For macro distributed, so they have 2 scenarios. So let me just highlight this now. So they have two scenarios. Support the ORU or ODU, okay, on a non-vRAN, and this is on-site and with open front hole. And then on the scenario two, the ORU and the VDU, the DU and the CU are virtualized. Okay. So if you look at this one, this is the type of implementation. So meaning the Open Run could be implemented into different scenarios. It's either the DU is on site with the virtualized function on the local infrastructure, and the VCU is located at the edge or the regional cloud. Or they could combine the CU and the DU on the edge cloud, and the ORU is located on site premises. And you can also separate this one on the edge cloud and the regional cloud. So it depends on the application. Like for example, in the dish network, they have what they call the um, distributed DU and the DU on premises. So meaning the distributed unit are together with the radio unit in on cell site premises. And there are also uh, areas where the DU are centralized. So it depends on the implementation and scenarios. Run sharing and more run distributed scenarios. So we have also different scenarios like this. Okay, so if you're part of the solution team in an organization, you might be interested in reviewing this kind of technical priorities. So you can have an idea what would be the trend or what are the different best practices or applications that might be implemented using Open Run. Okay. Okay, so now we'll proceed with the different orange use cases, so we can give way to our next speaker. No, the orange use cases. So there's a lot of opportunities in vertical industries, like for example, customization and flexibility, scalability and optimized network capacity. Okay, network slicing and dedicated services provisioning, cost efficiency and reduce capital expenditure, enhance security and privacy, service reliability, and then management orchestration and energy efficiency. So what we have seen in the US tour is that most of the um, organization are very particular in the power saving feature of Open Run. So they really want to save power on this one. No? So they want to reduce the power consumption while maintaining the network quality. So they're implementing it in the Run Intelligent Controller. They call it the power saving X app. Okay. So what does it mean, the power saving? So for example, you are in a room and then you will use this what is so-called the meeting room, no? So what you do, kapag nandun yung mga tao sa loob, you will open the lights, right? So once you completed the meeting or you finished the meeting and everybody goes out, no, sa room, you need to turn it off. So ganoon din sa cell site, no. If no one's using the cell site because the subscribers are sleeping or not so active, so you need to turn off, no, some radios, no, or some features of the system. But this one is not uh, being optimized if naka-ano lang siya, no, naka-automated lang siya. It should be powered by artificial intelligence. So what is the difference between automation and and powered by artificial intelligence? So for example, yung mga traffic light system natin. So most of them are automated. So meaning probably 20 seconds magre-red and then or 20 seconds mag-go and then 120 seconds magre-red, no? So sobrang tagal. So if there's somebody na, for example, our grandmother, no, is trying to cross the road, it will not discern, no, kung matanda yung tumatawid o hindi. Unless this is powered by artificial intelligence. Meron siyang camera and then it will identify that somebody is crossing the street and it will give more time, no, before it goes to a go signal. Okay? So merong powered by artificial intelligence. So we want this also to be activated, no, sa radio access network. So kaya isa itong power saving control ang tinitingnan nila, no? Because it will drive more savings in terms of the OpEx, operational expenses. And isa rin sa mga applications or use cases na nakita natin is the ORAN use cases sa Brazil. So they use this use case sa medical sector. They call it the Open Care 5G ecosystem. So they deploy 5G using an open RAN system and using different entities of the ecosystem. So the project management was led by Deloitte, and then the system architecture and the blueprint of the Open RAN was supported by Telecom Infra Project or TIP. And then yung mga medical solutions and equipment by Siemens Healthineers. And then the radio and Open RAN solution by Airspan. Okay? Of course, this will be supported by a regulatory body and advocacy support. So merong suporta ng gobyerno to. Okay? There's a research and promotion of innovation by the Innovac HE, Hospital Clínicas. And then included din no yung academe, yung Polytechnic School at University of Sao Paulo. So that includes technology scaling and research methodology. And surprisingly, the core network was provided by a bank. So they use the IT infrastructure of the bank, which serves as the 5G network core. So the IT infrastructure of Itaw Bank, no? And the system integration, yung nagkabit-kabit lahat ng system is NEC and the management of network users. Okay. So implementing Open RAN needs a lot of ecosystem players. So that's why it's implementable as we see in other use case in different countries as well. What else? Meron tayong implementation ng Open RAN naman in terms of I'm looking at this one. So network sharing, no? By parallel wireless. So we call it the MOC-N. So MOC-N means multi-operator core network. So it helps the new operator Mayutel to build 3G, 4G Open RAN networks in 3 months. So they just use radio access network to share with Telefonica's core network. So ginamit nila is Open RAN din dito. Okay, so so those are the different use cases, no, of Open RAN.